I've figured out how to turn glue into drinkable alcohol. We're going to go through the whole experiment together. But first, here's how this is even possible. Most kids' glue is made of PVA, polyvinyl acetate. PVA has acetate groups, and if you remove them, you get acetic acid, basically pure vinegar. I started with a full gallon of Elmer's glue. That's a lot, 3.78 liters. But I had no idea how much PVA was actually in there, or how efficient this would be. Step 1, remove the water. Glue is about half water, so I had to get it out. At first, I just left it out to dry, but the top hardened and trapped water inside. 2 weeks later, it still wasn't fully dry. I chopped it into smaller chunks and tried a food dehydrator for a week. Better, but still not dry enough. Finally, I put it in a vacuum oven, and after several days, I had hard, dry blocks of almost pure PVA. Step 2, make the blocks small enough to work with. These blocks were too big for my flask. I tried a food processor, a blender, and even a hammer. Nothing worked. Eventually, I got a cheap wood chipper, shredded the glue, and ended up with small chunks the perfect size. Step 3, turn PVA into acetic acid. I put the chunks in my largest flask, set it in a heating mantle, and added a 3-way adapter with a thermometer and a condenser. I connected it to a vacuum pump to keep oxygen out since glue could burn. I heated slowly. At first, nothing happened. Around 70 degrees Celsius, I saw fogging and tiny drops forming in the receiving flask, mostly water. At 160 degrees Celsius, the liquid started turning yellow. A good sign. The glue was breaking down. Soon it got darker and started producing smoke. Most of this was acetic acid forming, but there were other nasty chemicals too, like acetone and benzene. I set up an ice bath to condense the vapor. As the main flask reached 200 degrees Celsius, it turned red with black residue on the sides. The other flask's liquid was dark too, full of impurities. After about an hour, the temperature spiked to 380 degrees Celsius, meaning almost nothing was left to collect. I poured it into a separatory funnel, discarded the black oily layer, and kept the good stuff. Step 4, test for acetic acid. I used pH paper. It turned reddish pink. Acidic. I added distilled water, which made it white as the oil separated. Then I slowly added baking soda, which frothed and fizzed as it turned the acetic acid into sodium acetate. This took nearly an hour and about a kilo of baking soda. Next, I heated it to remove volatile stuff like benzene, leaving behind solid sodium acetate. I washed it with acetone multiple times, watching the liquid turn dark red and yellow as impurities were removed. Finally, I dried it in the vacuum oven. Step 5, turn sodium acetate back into pure acetic acid. I added concentrated sulfuric acid. It reacted immediately, releasing white vapor, acetic acid, and leaving behind sodium sulfate. I collected the acetic acid in a flask, but it still had water, so I added DCM solvent and magnesium sulfate to dry it. Finally, I did a fractional distillation, first removing DCM and water, then heating to 118 degrees Celsius to collect pure acetic acid. I ended up with around 100 milliliters of pure vinegar. Tests confirmed it was real acetic acid, completely pure and ready for the next step. Step 6, make ethanol. I used dimethyl sulfoxide as a solvent and sodium borohydride as a reducing agent. I added acetic acid slowly. It bubbled and produced hydrogen gas, forming an intermediate called sodium triacetoxy borohydride. Then I added methane sulfonic acid dropwise, which catalyzed the reaction to turn the intermediate into ethanol. I cooled the mix in a water bath to control foaming and finally quenched it with a basic sodium hydroxide solution. Step 7, purify the ethanol, also known as alcohol. I distilled the mixture. Low boiling impurities came over first, including dimethyl sulfide, which smelled awful. When the temperature hit about 80 degrees Celsius, ethanol began to collect, mixed with water. I did another fractional distillation to separate ethanol from water. After multiple distillations and filtering through activated charcoal, I ended up with about 90 milliliters of 68% ethanol.